So topic 3.1, today we're going to look at angle relationships that are formed by parallel lines. So we've looked at some angle relationships like vertical angles, supplementary, complementary, linear pairs, things like that. These ones are specifically formed by if you have parallel lines. So let's get some vocab out of the way first. Simply parallel lines, you've heard of them, you did them in Algebra 1. Parallel lines are simply two lines that do not intersect. Technically, two or more lines that don't intersect. But for right now, we're just going to focus on two. Two lines that do not intersect. So if you look at this cube shape here, think of your sides of the cube as like planes, right? And then think of your edges as lines. So there would actually be a lot of different parallel lines in this cube. For example, maybe if you looked at these top two edges of your plane, or of your box, I'm sorry. Wouldn't those technically be parallel lines? Yes, they're never going to intersect, right? They're in the same plane, they're never going to intersect. I'm going to, just for the sake of this example, I'm going to call this line A, and I'm going to call this line B, because there's a special way you're supposed to show things are parallel, like how perpendicular lines, you do your upside down T. To write parallel lines, we would say line A is parallel to line B, and your parallel symbol is literally two like little parallel lines. Like it almost looks like an 11, but they're two little parallel lines, and that's your symbol. Then we have skew lines. Skew lines are two lines that do not intersect, but also they're not parallel and they're not in the same plane. So they will never intersect, they are not parallel, and they are not in the same plane. So if one's like at the top of your box, the other maybe is at the bottom of your box. An example of skew lines would be maybe like this back edge here with this bottom right edge here. That top edge, right, it's up at the top of your box, it's going left and right. And then that bottom one, it's at the bottom of your box and it's going front to back, right? So one's at the top of your box, one's at the bottom of your box. They're not parallel, one's going left, right, the other one's going front to back, and they're never going to intersect. So that would be an example of two skew lines. Okay. And that there's no special symbol for skew. We just talk about it. There's no special way to write it though. Parallel planes. These are planes that do not intersect. Would your box maybe have some parallel planes in it? Yeah, maybe. What would maybe be an example of some parallel planes in your box? Yeah, sure. Maybe the front plane and the back plane. What else could maybe work? Or the front and the back of your boxes, right? What else could maybe work? Yeah, the left and the right, bottom and top, right? Those would all be parallel. So when I'm talking about parallel planes, right, these are two planes that do not intersect. Then our last vocab word for this little part here is called a transversal. A transversal is a line that intersects two or more coplanar lines at different points. Two or more coplanar lines at different points. What this is going to look like, I'm going to draw this kind of off to the side here. You would have two lines. It doesn't really matter if they're parallel or not. I'm just going to draw two lines. Okay. Pretend that they're straight, I guess, though. And if there is another line that intersects both of them, that is a transversal. Okay, so this line here would be a transversal because it's intersecting those two purple lines. Ethan? Okay.
Advisory days?
Uh-huh.
How are we going to be doing it?
With remote, you're all going to be doing it on the same day. So your next advisory day will be October 8th. And then the next week you won't have it. And then the week after that, it'll be the Tuesday. Then you won't have it, then the Thursday. Okay? And the dates on the actual like advisory course on Canvas will be updated soon. Yeah. All right. So now when you have a situation like this, guys, when you have lines and you have a transversal cutting through them, this is when our special angle relationships end up happening. So look at this chart here. In this chart, we're going to talk about angles that are formed by transversals, right? They have special names and they have relationships and properties and things like that. So in our first column here, we have the names. Then we're going to take a look at a picture of what they would look like, and then some theorems that go with them. So our first type of angle, these are called corresponding angles, corresponding angles. And I'm going to actually do, I'm going to show you what they look like. So a corresponding angle, what they end up looking like is they both kind of are, they're both either on the left or the right of your transversal and both above or below the two parallel lines. What they do, each one of these is going to have a little like letter that is associated with it to help you identify it. Corresponding formed by, or will have a little F shape. So I would write that down. They have an F shape. So for example, I'm going to label this angle here is angle 1, and this angle here is angle 2. Those would actually be corresponding angles. They're both on the left of the transversal, and they're both above those two lines. And if you take a highlighter or a pencil or whatever, and you box in the corner where 1 is, and you box in the corner where 2 is, it might be upside down and kind of slanted, but isn't that kind of like an F shape? Yeah. Again, your letter might be upside down, might be slanted, might be going the other way. It kind of is, yeah. But it makes like that little F shape. So if you box in your corners with a highlighter, it's nice and easy to see. So this is what corresponding angles would look like, and they could end up on the other side of your picture too. It's just one example. Corresponding angles, though, are going to have a special relationship, and that is called the corresponding angle postulate. And it says if lines are parallel, so if these two lines here were parallel, then the corresponding angles are congruent. So if the lines are parallel, then the corresponding angles are congruent. And we can actually then use that at some point to prove that angles are congruent. You can also take this postulate and you can flip it around and look at its converse. If you have a situation like this where the corresponding angles are congruent, then that would mean the lines must be parallel. So if the lines are parallel, the angles are congruent. If the angles are congruent, the lines are parallel. And then most of them will kind of go in that kind of an order. Now we have alternate interior angles. Okay, so alternate interior angles, these ones kind of make a Z shape or like a little like zigzag or a lightning bolt depending on the picture. So an example of where alternate interior angles are, also look at the words. Alternate, like opposite, right? And then interior. Interior, see those two lines? Interior means it's going to be between them. Exterior would mean it was literally on the outsides of them. So if we're talking about interior angles, we're just talking about things between these two lines. So one example of alternate interior angles would be like this angle and this angle. I'll call this one 1 and this one 2. And then again, if you take your highlighter and you box in those corners, you'll see your Z shape. So if I box in this corner, box in that corner, don't you have your Z shape?
Yeah.
Excellent. Thank you. All right. Then our relationship here is pretty similar. If these lines end up being parallel, then our alternate interior angles are also congruent. Ooh, except that doesn't look like a congruent sign. There. And then you can also take that statement and flip it around. If alternate interior angles are congruent, then the lines must be parallel. So if the lines are parallel, alternate interior angles are going to have to be congruent. If alternate interior angles are congruent, then our lines are parallel. Next angle relationship is alternate exterior angles. Alternate exterior angles kind of do this like opposite V shape. Like one V is going one way and one V is going the other way. So exterior means now they're going to be on the outsides of those lines. So one example of alternate exterior angles would be this little angle here and that little angle in the lower left corner. And then if you box those corners in, right, this kind of, you box it in, it makes one V going like up and to the right. You box this one in, it makes a V going the opposite direction. So you have your like opposite V shapes. And for these ones, if our lines are parallel, then our alternate exterior angles are also congruent. Except I'm not doing a good job at drawing congruent symbols today. There we go. And then switch that statement around. If alternate exterior angles are congruent, then lines are parallel. Exactly. So if the lines are parallel, alternate exterior angles are congruent. If alternate exterior angles are congruent, lines are parallel. And then our last one, it's actually the only one that's any different. This one's not going to be this one's not going to be congruent this time. This one is called same side interior angles. And same side interior angles end up making this like kind of like a boxy C shape. Some people have referred to it like as a staple before. It almost looks like a little staple, or a boxy C or a boxy U, however you want to think about it. So same side interior, kind of like alternate interior, right? But same side. So that means they're both going to be on the left or they're both going to be on the right. So for example, if I looked at this little angle here and that little angle there, those would be alternate interior angles. It's hard to write this small on here. Those ones. Okay. And if you take that and you box it in, right, box in your one corner, box in your other corner, and you have your little C shape or staple shape. Now these ones are different. If you notice these pictures, every angle is either like an obtuse angle or an acute angle. Do you notice that about your picture? And in all these previous pictures, these had been like two acute angles, right? Two acute angles. In this one, two acute angles. But in this one, isn't angle 1 look obtuse? Doesn't angle 2 look acute? So those can't be congruent. In this situation, if your lines are parallel, then same side interior angles are going to be supplementary. And if same side interior angles are supplementary, then your lines will be parallel. So that's the only one that's a little bit different. Any questions yet? The rest is pretty much just identifying and like doing some examples. So this pictures like this are going to be very common in this chapter. That's why it says know your way around this picture. I wish I could physically like cover things up for you guys and talk about them. But if you kind of ignore angles, I'll just don't actually cross this out when I do it. But like if you just kind of ignore this part down here and you just look at lines X, Y, and T, doesn't that kind of look like the pictures that were in our examples here? That kind of shape happens a lot. And then also, if you maybe ignored like the top and just looked at Y with Z, that shape happens a lot. The difference is lines X and Y are parallel. Z is not parallel to those. Another important little symbol I want to point out to you. In lines X and Y, you guys notice these little like triangle shapes? The little triangle shapes or little arrow shapes in your lines are there to tell you that they're parallel. That's a little like parallel symbol in your picture. So lines X and Y are parallel. Z is just kind of doing its own thing down here. So we're going to identify these things in our picture. First thing it wants me to identify are some vertical angles. There are probably like 20 pairs of vertical angles in this picture. Let's just identify maybe 2 of them. Okay. Where would we have, I know that this one's an old angle relationship, but it's going to keep coming back. We're going to deal with vertical angles pretty much all year. Remember, look for your X's. They're the ones on either side. Where do you guys maybe see some vertical angles in this picture? Ethan? 6 and 7, absolutely. Yep, 6 and 7 here, you have your X shape. Those would absolutely work. So angle 6 and angle 7. Good. Oh, and I told you guys I'm going to start calling on people at home today. So get ready. Get ready, people at home. Your time is coming. Because also too, I tend to call on people more when no one's volunteering, you know what or if the same like 3 people are volunteering every time, I'd be like, all right, I know you know what you're doing. I'm gonna call on somebody else. What would be another pair of vertical angles? And people at home, you can always like pipe up to save yourself from just being randomly called on. L? 2 and 3, absolutely. That would be another good example. Angle 2 and angle 3. And there's obviously lots more you can name, right? 9 and 12, 5 and 8, they go on and on forever. Linear pairs. I'm going to scoot this over. But while I scoot this over, take a second, try to identify some linear pairs. Remember, linear pairs, you are going to look for your opposite rays, and they're going to be adjacent to each other. Where do we maybe see a linear pair? Anyone online? Any suggestions for a linear pair? Angle 1 and angle 3. Thank you, Gannon. Absolutely. Angle 1 and angle 3 right here. They are adjacent, and we have our opposite rays going on. Very good. So angle 1 and angle 3. Okay, now that we have an example, can anyone name another pair? Another linear pair? 2 and 4 would absolutely work. That's just on the other side, right? Angle 2 and angle 4 would also work. 5 and 6 would work. 6 and 8, 1 and 2, right? The list goes on. Pretty much anything that's next to each other in this picture could work. Adjacent angles. This is more just to review our vocab. What are adjacent angles? Adjacent. I don't know. If I said like the person adjacent to you, where would they be? They'd actually be next to you. Yeah, they'd actually be next to you. Adjacent angles are just angles that are next to each other. They share a vertex and a side. So one example of adjacent angles here could be like 3 and 4. Angles 3 and 4 would be adjacent. They're next to each other. So now that we have an example, can we find another one? Sure, 5 and 6. Actually, and also all our linear pairs are adjacent, so those would be the same as well. Okay. Now we want to identify a pair of congruent, and actually we're going to skip 4. I don't like 4. 4 is stupid. We're going to move on. And we're going to skip 5. I don't like 5. 5 is stupid. Saving us time. But we are going to talk about 6. Which line here would be the transversal? Think about what we did up here, right? Our transversal was our line that cut through our other lines. So if you're looking at this diagram here, which line is cutting through the others? Trey? T. So here, line T would be our transversal. Good. And I tend to draw a weird cursive T so it doesn't look like a plus sign. But you can do it however you want. Questions, concerns on the first page? All right, onward. On to the next page. Parallel lines. Which lines here would be parallel? I kind of told you already. Trey? X and Y. If I didn't tell you that they were parallel, what little symbol is in there that would tell you that they were? The little triangles, sometimes they're little arrows, okay? And we're going to write this properly. We're going to say X is parallel to Y, like that. We're going to use our symbol. X is parallel to Y. Are there any perpendicular lines in this picture? No. What would we need if they were perpendicular? We would need some right angles, and we don't have any of those. So we're going to say none. There are no right angles in this picture. So no perpendicular lines. Okay. Part 9 says interior angles for lines X and Y. This is just a list. I want you guys to look at lines X and Y and determine, okay, which angles would be on the interior of X and Y. Trey? 3 and 6, what else? Yeah, so 3, 6, 5, and 4. Yeah, these ones you didn't have to do alternate interior, just general, like which ones are on the interior. So yeah, if you're just looking between X and Y, that'd be 3, 4, 5, and 6. Good. I have a lot of trouble drawing 3s with this stylus. I don't know why. 3, angle 4, angle 5, and angle 6. All right. Exterior angles for lines Y and Z. So it's telling you specifically to look at just Y and Z, right? If it's telling you a specific place to look, ignore your other information, right? Anything that's attached to line X does not help us with this problem. So if you're only looking at lines Y and Z, angles 1, 2, 3, and 4 don't apply because they're attached to line X. So what would maybe be on the exteriors of Y and Z? Ethan? 5, 6, 11, and 12. Exactly. Very good. Because it doesn't matter if it's not like on the exterior of your picture in general, right? It depends on which portion of your picture you're looking at. Good. Okay, now we're getting into our actual angle relationships that we just talked about today. So if you need to flip back to the front of your notes, please do so. Corresponding angles, these are the ones that form our F shape. So we're going to find a pair or two of congruent corresponding angles and a pair that aren't congruent. Now, what would be the difference? Well, congruent ones are going to be formed by parallel lines. Not congruent ones are going to be formed by lines that aren't parallel, right? So, and in this diagram, you have some parallel lines, you have some not parallel lines, so there's going to be both happening. If I'm looking for just congruent corresponding angles, then I want to ignore line Z. It's not going to help me, because is line Z parallel? No. So I only want to look at angles that go with X and Y. And I'm going to identify one pair, and I'd like you guys to identify one or two other pairs, okay? So one pair of corresponding angles here. Again, you're looking for your F shape. So I'm going to say that angle 3 and angle 7 would actually be a pair of corresponding angles here, 3 and 7. They make your F shape. They're both on the left of your transversal and below those parallel lines. So angle 3 with angle 7 would be one example. What would be another example if 3 and 7 works? Trey? 2 and 6, absolutely. That's just kind of like your upside down F shape, right? So angles 2 and 6. Ethan, did you have a different one?
4 and 8.
4 and 8 would also work. That would be a really nice F shape, right? If you boxed 4 and 8, that would totally work. Good. Good. All right. Now we're looking for ones that are not congruent. So not congruent means don't look at your parallel lines, right? We want to look at lines that aren't parallel. Now, Y and Z aren't parallel, so we can look at ones formed by those. X and Z also aren't parallel. So you could also kind of ignore Y and look at X with Z, or you could ignore X and look at Y with Z. It's up to you. And I mean, what I like to do when I'm like actually teaching this on paper is I like to physically like take a Post-it note and cover up portions of the picture. So like you guys can always like take an index card or your hand and like cover up portions. It can help when there's a lot of extra information. So I'm going to pick out a pair that aren't congruent, and then I'd like you guys to pick out some more for me. So one that would not be congruent would be, and I'm going to give you one that goes with X and Z, and then it's up to you. Angle 3 and angle 11 would be a pair that are not congruent. Because isn't line 3 or angle 3 up there on line X? And then angle 11 is there with line Z. So if you box in here, right, and then that'll kind of continue, and then here as well, that would be like this weird little light lopsided F shape. So that would be one example. That's a trickier example though. I just wanted to point it out to you though. So that's angle 3 and angle 11. Anyone at home have an idea for me for not congruent corresponding angles? 8 and 12, absolutely. Angles 8 and 12, right? Y and Z are not parallel, but you'd still have your F shape. Very good. Angle 8 and angle 12. Anyone else at home have another idea? Oh, come on, guys. There's more than 2 people at home. 9 and 1 would absolutely work. Yes, we'll add that to the list. 9 and 1 is good. Yeah, and that's okay. That's okay because it's still formed on X, and X and Z aren't parallel. So that's another good like trickier example actually. All right, people at home, you had more time to think. I'm not letting you off the hook. What's another one? 7 and 11. Thank you, Anna. Yes, 7 and 11 would also work. Anna saved you guys. I was gonna just pick a name. I don't know, whichever one I looked at first. All right. Good. We got a nice long list there. The more we can identify, though, the better, because that's more practice for you guys. All right. Now we're going to look at alternate interior angles. First that are, then that aren't congruent. So alternate interior angles, that's going to be your Z, your Z or your zigzag shape. Okay, lightning bolt, zigzag, whatever. So again, if they are congruent, we are looking at only the parallel lines, so you can kind of ignore line Z right now, which would be angles 9, 10, 11, and 12. There's actually only 2 examples of ones that are congruent. I'm going to give, Trey, yes. Absolutely, 3 and 6. Angle 3 and angle 6, good. Yep, that would work. And you'd have your Z shape right there. Good. Somebody else got another one for me? Colin, you got one back there for me? If 3 and 6 work? Yeah, exactly. If 3 and 6 work, then 4 and 5 definitely work too. Good. Then your Z shape would just be going like the other way, right? But that's okay. Good. So 4 and 6. Or 4 and 5, I'm sorry. Angle 4 and angle 5. Good. I use way too many different colors for no reason right now, but that's okay. All right, not congruent angles. Take a second, see if you can find some not congruent angles. Think about that same thing we just did. Let me rewrite these and then Ethan, you're up first. All right, Ethan, what's your idea? 7 and 10, absolutely. You would have your Z shape right there. Very good. Try. 1 and 12 would actually be alternate exterior, not interiors. 3 and 10 would work. Yeah, absolutely. Good. Somebody at home who is not Anna or Gannon, because I know that they already participated once. I don't know who the other person was because I wasn't looking. 8 and 9 would absolutely work. Good. Thank you. 8 and 9. Good. Oh, someone chatted. 3 and 10. Yes, 3 and 10 would also work. Oh yeah, and yeah, Trey said that one, but good, Tyler, that would definitely work. All right, we feeling okay about those so far?
Yeah.
Good. All right, alternate exteriors. So now exteriors, right? Look like when you're going to focus on 2 lines, you're going to look at the ones that aren't between. So alternate exteriors make your opposite V shape, like this kind of. I'll have to zoom out a little bit so you guys can still see the picture. So alternate exterior angles that are congruent. Again, are congruent means we're looking at the parallel lines, which means only look at angles that are formed by X and Y. So what do we maybe think? Al? Would it be angle 2 and 7? 2 and 7, absolutely. Yeah, angle 2, you have kind of your V shape going this way. Angle 7, you have your V shape going that way. Absolutely. Angle 2 and angle 7. So if 2 and 7 could work, what do we think for another one? Someone at home, if 2 and 7 works, what else could maybe work? Which one, sorry? 8 and 1, yeah, absolutely, Colin, 8 and 1. Good. And that's actually it for ones that are congruent, because your options are more limited. Now, ones that aren't congruent, we can again look at either X with Z or Y with Z. So Trey, you had that other one you said before. What was it? Yeah, 1 and 12 would definitely work, right? These are totally exterior. Good. So 1 and 12 would work. And keep in mind too, guys, if you're looking at like Y with Z, you can ignore anything associated with X. So if you look at just Y with Z, technically 5 and 6 would be exterior to those two. So what would maybe on that note, what would maybe work with angle 5? If one of the ones you pick is angle 5, what would be the other alternate exterior angle with that? Again, we're ignoring line X. Yeah, 12. 5 with 12. Exactly. Good. All right, somebody at home who I haven't heard from yet, give me another example of alternate exterior angles that are not congruent. Let's see. Rosalind, any ideas for us? Alternate exterior angles that aren't congruent? 2 and 11, absolutely. Angle 2 and angle 11. You had an idea. You were just holding out on us. All right, excellent. Questions about that one? All right. Last one of these, same side interior angles. This time it's supplementary versus not supplementary. So, again, if you're looking for ones that are supplementary, look just at your parallel lines. These ones form that boxy C or that staple type of shape. What could be an idea here with ones that are supplementary? This time, remember, you're picking out an acute and an obtuse. L? 4 and 6, absolutely. Angle 4 and angle 6. Good. If 4 and 6 work, then Ethan, what else works? 3 and 5. Very good. And that would actually be the only ones that are supplementary. Now there's a lot that aren't supplementary though. So again, now look at your not parallel lines. So X with Z or Y with Z. What would maybe be an example of ones that are not supplementary? Ethan? 8 and 10, absolutely. You still have your C shape, right? But these lines are not parallel. Good. 8 with 10. Somebody at home, if 8 and 10 works, oops, what else would have to work? Yeah, 7 and 9, exactly. Thank you, Anna. 7 and 9 would also work. Yes. 10 and 4 would work, yes. They absolutely would. Those ones just go with lines Y and Z, right? Or I'm sorry, X and Z. But yeah, you'd still have your C shape. Good. That would definitely work. I meant to do these in green, but that's okay. Good. 4 and 10 would also work. Excellent. Any questions about any of those? Do we feel okay about identifying? Okay, good. I feel like we did pretty good with it. All right. All right, so now for this part, we are going to look at ones that we have a diagram. Our diagram is labeled, right? We have some variables and stuff, which means we're probably going to have to set up what? We have to solve for a variable. We have to set up an equation, which we do a lot in this class. I don't know if you've noticed that yet, but you need your algebra skills a lot in this class because what ends up happening is we apply like new geometry vocab and then you have to write an equation about it. And I would say that's at least half this class. So what we're going to do for these is we are going to first identify what angle relationship is happening. Do I have parallel lines or not? And then are they supplementary or are they congruent? Because that's going to tell us how to set up an equation. So first of all, do I have parallel lines in this picture? Absolutely, because we have the little arrows, right? So step one is complete. That means our angles are either going to be congruent or supplementary. Next, we have to decide which angle relationship is going to happen. I would say keep variables, keep like terms together. So like x's with x's, y's with y's. Here I have an x term in this corner and an x term in this corner. So if you need to, you can flip to the front. What angle relationship would this be? These are alternate exterior angles. Good. So these are alternate exterior angles. And if you look at your theorems on the front, if you have parallel lines, then what can we say is true about our alternate exterior angles? They're congruent. Good. And if things are congruent, that means they have equal measures, right? So if things are congruent, you basically end up just setting them equal to each other. Exactly. So we're going to set 11x minus 7 equal to 9x plus 7. And then we're going to solve. Colin, are you awake back there? Colin, you awake back there? Okay. All right. So first algebra step. Oh, and I do kind of expect us to be able to solve algebra equations. If you struggle with them, let me know and I can give you some good tricks and stuff, but I don't do minus 9 on both sides. I don't show all that. If you need to, you can, but so on this one, I'm going to subtract 9x from both sides. That's going to give me 2x minus 7 equals 7. Then I'm going to add my other 7 over. That's going to give me 2x equals 14. And then I'm going to divide by 2 to get 7. It just says to solve for the variables, so I don't need to plug it back in. I'm just done there. So again, identify, are your lines parallel or not? What angle relationship is happening? Do I have to set them equal? Or do I have to add them up and set them equal to 180? Because that's going to be our other option. Now here it also wants y though, doesn't it?
Yeah.
I threw this on here because I've noticed we get confused on this on our quizzes and tests. If you look at another nice thing, a little trick for these is when your lines are parallel, these are all going to be made up of acute and obtuse angles. And if you look at 11x minus 7, doesn't that look acute? Yeah. And doesn't 9x plus 7 look acute? So you'd be like, oh, they're equal. So they're both two acute angles. But if you look at y, does that look acute? No, that looks obtuse, right? Okay. So that means it's not going to be equal to the other ones. Instead, it's going to be supplementary. This is actually making a little linear pair here. So if I know that x is 7 and I want to find y, what could I maybe do with 7 to help me solve for y? Ethan? Yeah, very good. I'm going to plug 7 in and I'm going to see what this angle would have been. So that's 9 times 7 plus 7. 9 times 7 is 63, plus 7 is going to give you 70. So I know that this angle is 70. And then I know they're a linear pair, so they're supplementary. So to find y, I would just do 180 minus that other angle, which is 70, to get 110. That's likely to show up on your quiz, just so you guys know. All right. Let's look at number 2. Okay, so again, do we have parallel lines? Yes. So then we need to identify our angle relationship. Any ideas on what that might be in this one? You need to, highlight it, box it. It just doesn't do me it doesn't do you any good if I tell you every time. They are alternate. but they're not exterior. They're interior. Yep, these are alternate interiors. If you box this corner, yeah, that helps a lot. This is a good one to like, and I always have highlighters if you guys ever want to borrow one, but this is a good one to like do that and then see. So yeah, then you see your Z shape and you know that they're alternate interiors. Okay, then go to your front chart. If they're alternate interiors, are they congruent or supplementary? Congruent, so set them equal. 8x plus 8 equals 7x plus 17. And then I'm going to solve. Subtract your 8x over, that just gives you x plus 8 equals 17. Subtract your 8 over, and you should get 9. All right, so now that I know x is 9, I'm going to need to use that information to solve for y. Now again, look like your acute versus your obtuse angles. 8x plus 8 looks acute, right? 7x plus 17 looks acute. What about y? It looks acute. So is that going to be equal to or supplementary to the other angles? Well, if they're both acute, they're going to be equal to. If you take a look here, don't you have your little X shape? These are vertical angles. Okay, so y is a vertical angle with 7x plus 17. So we're going to use that same strategy we used on the first one. I'm going to plug 9 in. So I'm going to plug 9 in here. That gives me 7 times 9 plus 17. 7 times 9 is 63. Plus 17 is 90. I know it doesn't look like a 90-degree angle, but that's okay. You just go with what the numbers tell you. So if that angle is 90, what's y going to have to be if they're vertical angles? Also 90. Good. Good. Are these the last two on here, or is there anything after that? I can't see it on mine. Oh, there are. Okay, there's some parallel things. Okay. All right. Number 3. Box in your shape. All right, box in this corner. Box in this corner. Somebody at home, what angle relationship is this? Yes, good, Colin. These are same side interior, and then somebody else. If they are same side interior angles, go to the front page. If they are same side interior angles, are they going to be congruent or supplementary? Supplementary, good. And if angles are supplementary, that means they're going to have a sum of what? 180. So what you're going to do in this situation is add them up and set them equal to 180. So 13x plus 15 plus 6x plus 13 equals 180. Now, be careful on these. I've seen a few silly algebra mistakes here where people are subtracting things from one side of the equal sign. You only want to subtract or add things to opposite sides of the equal sign. So I'm not even going to subtract my 13x or anything like that yet. I'm going to first combine my like terms, okay? So combine your like terms, and 13x plus 6x is going to give you 19x. And then 15 plus 13 is going to give you 28 equals 180. Does that make sense, guys?
Yeah.
And then I'm going to subtract my 28 from both sides. That's going to give me 19x equals 152. And then 152 divided by 19 is going to give you 8. Okay. Good. Questions about that one? Okay. All right, number 4. Box your corners here. Box that one. Box that one. Look at the front if you need to. Yes, these ones would be corresponding. So go to the front if you need to. Danny, would corresponding angles be congruent or supplementary? I'm not sure if we don't know or if I'm frozen because I think my picture looks frozen, but my screen's not. You there, Danny? Can you guys at home hear me? Okay, so Danny's just not answering. Tyler, what do you think? Would corresponding angles be congruent or supplementary? They would be congruent. So we're going to set these equal to each other. So 13. So 13 plus 16x equals 6 plus 17x. And then we are going to solve. I don't want to do all this algebra for you guys. I want you guys to help me with it because there's no point in me doing it. I know how to do it. So Anna, what would be my first algebra step? Sure, yeah, you can do it that way. We can subtract our 16x. Do you like working with positives, Anna? Yeah, that's fine. You can do that. Did you have to subtract the 16 though? No, you could have subtracted the 17 if you want. It's totally up to you. Either way that works. And then Colin, what would I do next? Colin K. Online. Yep, subtract your 6 over and you would get 7 equals x. And if you solved it the other way, it's just x equals 7. That's the same thing. Good. Nothing extra to do there. Good. Questions about those? That'll be probably a good chunk of your test. Will be identifying and then solving. And then last thing, and then you'll have the rest of the time to work on your homework, is just determining which lines are parallel. Now, this is kind of like the opposite of what we just did. We had parallel lines, so we knew angles were congruent or supplementary. Now we're going to have to see, are any angles congruent or supplementary? And if they are, which lines do they make parallel? So if you take a look at example 1 here, are any angles marked as congruent? No. No? In number 1 here, nothing's marked as congruent? If you look for the little arcs.
Oh, I see it.
You see what I'm saying? Yeah. Oh, yeah, no, nothing's marked as parallel. You're right. We're going to figure out what's parallel. But yeah, right here we have our little arcs. So this corner and this corner, and then it helps too if you just like highlight it, because then we can clearly see that's our F shape, right? So Gannon, if this is our F shape, what angle relationship would this be? That would be corresponding. Good. So we have corresponding angles. So we have corresponding angles that are parallel, or I'm sorry, that are congruent. That's going to make our lines parallel. But the question is which 2 lines? There's a lot of lines happening here, right? Well, does this have anything to do with line R? No. Does it have anything to do with line S? No. And then if it doesn't have anything to do with line S, would it make sense for T to be parallel to something? No. So which 2 lines would need to be the parallel ones? P and Q. Good. So how we would, and it says explain. So what we would do is we would say P is parallel to Q because corresponding angles are congruent. That's how we would say that. Good. Now, those are the only ones that are marked as congruent. Are there any that are supplementary that you see? Because that's the other relationship that can happen. If they're supplementary, they'll add up to be what? 180. Well, what's 80 plus 100? 180. So would that little 80 degree and that 100 degree angle be supplementary? Yes. So if you box those in too, you can see that we have supplementary angles. And what relationship is this? Hannah, Cruz, sorry. What angle relationship would this be? Same side interior, but yes, same side interior angles, good. So these are same side interior angles. They are supplementary. Can someone tell me which lines they're making parallel? Ethan? Q and R. So we would say that line Q is parallel to line R because same side interior angles are supplementary. Good. Good. Last one. All right, number 2. This one, remember that if there's one arc goes with one arc, right? 2 arcs goes with 2 arcs. So let's look at the 1 arcs first. This angle here is marked as being congruent with this one. So let's box it and see if we see an angle relationship. So I'm going to box this corner and then this corner. Huh. Does that look like anything we've dealt with? Now, does that look like a Z or an F or a C or opposite V's? Not really. You gotta look at where they overlap, right? And isn't this angle an interior angle? This one here. And isn't this angle an exterior angle? There's actually no relationship where one's interior and one's exterior. They're either both interior or both, well, I guess corresponding are, but then they'd also be on the same side. So that one's not doing anything for us. That doesn't help us in any way. So let's look at a different set. Here we have 2 angles. Ooh, the green over the pink is bad. Okay. So here we have 2 congruent the congruent marks, and then here we have congruent marks. Natalie, what angle relationship would that have to be if that's that F shape there? Would it be corresponding, alternate interior, alternate exterior, or same side interior? You can look at the chart on the front if you want. That's okay. Here, we can go back up and look. I certainly don't expect you to have it memorized yet. So here, we can look at our chart. So we have our corresponding, which makes our F shape, our alternate interior, which makes our Z, alternate exterior is the V's, and then same side interior would be C's. Yep, absolutely. Does that make sense, Natalie? Okay. All right. So those would be corresponding. They're congruent. So will we have parallel lines? Yes. Which 2 lines would have to be parallel? Ethan? H and J. And that's the other nice reason to highlight. Doesn't it make it a little clearer which lines would have to work if they're highlighted? I think so, at least. Okay, so H would have to be parallel to J. So H is parallel to J. It's my weird little cursive J. Because corresponding angles are congruent. Good. Questions, concerns? How do we feel about identifying our angles? Pretty good. How do we feel about setting up the equations and solving? Pretty good. Okay, those are really the two main things. And then identifying some parallel lines maybe. Okay, well, good.